find the prime factorization of this number, we know that the circles have to be a prime number. The squares are composite numbers. And for this one, we started the circle as a 2. And so 2 times what gives me 108? 54. We all know that because sometimes you might have to do it off to the side. 2 goes into 10 5 times, 2 goes into 8 4. I just used some short division to figure it out. My circle means it's a prime number. So I'm going to use a 2 again. 2 times what?
27.
27.
3
and 9.
3 and 9.
And then
3.
3.
We did this one together. We have all of the prime numbers. 2 times 2 times 3 times 3 times 3. You write it down here. In numerical order, least to greatest. So 2 times 2 times 3 times 3 times 3. So then this would be, then you have to write it with the exponent. So I want you to write it 2 squared times 3 cubed. Starting with number 2. 2 and 20. Then we would have 10 and 2. Okay, I heard another example, and I'm going to go over that here in a second. And this would be 5 times 2. So we have 2 times 2 times 2 times 5. So 2 times 2 times 2 times 5, which would be 2 cubed times 5. Somebody said 4 and 5 with this one here. So they started at 40 and went down to 2 and 20, which works. You know, let me write it up here.
I did 5 and 8.
If I start with 40 and I start with 2 and 20, but they said 20 was 4 and 5. That's fine. My 2 is prime here, my 5 is prime. 4 would be 2 times 2. I still have 2 times 2 times 2 times 5. That's a correct answer. Somebody said they started 40 with 5 times 8. 5 is prime. That's fine. And then finish factoring 8. 2 times 4. Circle the 2. Factor the 4 with 2 times 2.
Same thing.
You still get 2 times 2 times 2 times 5.
Wow.
When you have the prime factorization, there are a lot of different ways to start it and end it. You just have to make sure that you're ending it correctly. If you don't end it correctly, that's where you made a mistake. So here's 3 options for one number, but we're coming up with the same prime factorization. 50.
5 and 10.
5 and 10. I'll use that.
5 and 2.
And then this would be 5 and 2. But don't write it down here as 5 times 5 times 2. You have to go least to greatest. So 2
I did 2 and 25.
times 5 times 5.
I did 2 and 25.
So
I got the
2
same
times-
answer. Guys, stop talking.
So 2 times 5 squared, you can do it a different way, just like we explained. There are 3 ways here. As long as you ended up with 2 times 5 squared, that is your correct answer. Make sure you've made any corrections that you may have needed to do. Then we're going to go down to the bottom. 75. 2 numbers that I can get to 75.
3 and 25.
I heard 3 and 25 first. So I'm doing 3 and 25. And then 5 times 5. You rewrite it 3 times 5 times 5. 3 times 5 squared. You can use 2 different numbers up there. It's fine as long as you got 3 times 5 squared. 60. I heard 2 and 30 first. And then I would have 15 and 2, 3 and 5.
Or you could do 10 and
So I have 2 times 2 times 3 times 5. 2 squared times 3
Cubed.
times 5.
Oh, no.
I have a lot of different ways I can come down to this. As long as you got to this, you are correct. 88, 2 and 44. And I'm just gonna say with 2 again. 2 and
22.
22. I'm gonna say with 2 again. 2 and
11.
so it's 2 times 2 times 2 times 11. Rewrite it to
2
cubed
times 11.
times 11. All right, in your math books, just put this paper off to the side. Oh wait, no, we gotta do the back. What am I thinking of? What? We gotta talk about perfect squares and cubed operations. So when we were doing this, it's very important for you to have your notes because it made life a lot easier with your notes. You didn't have your notes, it makes life difficult. You did not have to do the whole page, but we're going to go through the entire page. And you're going to put correct answers if you did not. When you have the base of 10, whatever its cube to or whatever the power is, that's how many zeros you're going to have. So this would be 1,
3.
and then it's cubed, so there are 3 zeros. I'm going to give you another example. If I have 10 to the 5th power, you would put a number 1 and then how many zeros?
5 0.
5. 1, 2, 3, 4, 5. So I go 1, 2, 3, comma. So it'd be 100,000. So make sure you're only in powers of 10. 11 cubed. That was not part of my answer sheets or part of my cheat sheets or part of my notes. So you actually had to do 11 times 11 times 11. Well, on one of your notes, you have 11 times 11, which is 121. So then all you got to do is take 121 times 11, and that answer 1,331.
Do we put a star on it?
12 squared. This is one you should have memorized. You need to get it memorized. It's a perfect square. 12 squared is 144. 3 cubed. We've seen this one a lot, so by this point we should probably have it. 3 times 3 times 3. 3 times 3 is 9. 9 times 3 is
27.
But this is how you show your work if you don't know what you're doing.
So, for the ones that you did for, like 1 and 3, since we were only supposed to use other numbers, you want us to put the
I just want you to put whatever work I might have on the board on your paper.
What is ring?
Because you might be able to use this for notes for a test or a quiz. 19 cubed. That was not one of ours that helped us. But what's 19 cubed saying? 19 times 19 times 19. I want you to write that down. You know 19 squared because it is on your papers. So 19 squared was what?
361.
So if I put arrows, I know that's 361. So then I just take 361 times 19. After I do all of that math, it's 6,859. I'm not going to sit up here and waste your time by showing you how to multiply.
Thank you.
By 7th grade, I think you know how to multiply. 16 squared. Should have it memorized.
Is that
256. Which 6, the 16 squared helps us when we come down to 7. Because the square root of 256 is 16. 6 and 7 are opposites, or they're inverse operations. Square root of 81 is
9.
9. Another one you should have memorized. The square root of 225 is
15.
15. Again, another one you need to have memorized. You can memorize and practice perfect square roots by going to my website and going to Fact Practice. Square root of 4 is?
2.
I gave you the answer.
Yeah.
Square root of 400 is?
20.
20. What's the difference between these two?
One just has a-
All this one, the only difference is this has zeros. So you add a 0.
Whoa.
Square root of 36 is?
6.
6.
Whoa.
And we're gonna move up to the bottom. We're almost to the down stretch. But these are cube roots. These are a lot more difficult. These make us think a little bit. As we talked about yesterday, if I pull out the 8, I'm left with zeros. So the cube root is saying something times itself 3 times gives me 8,000. If there's 3 zeros, I need to put in my zeros. And then so what's the cube root of 8? 2. So your answer is really 20. I need to see all that work on your paper.
Got it, man.
14, the cube root of 1,728. Well, if I know the cube root, we're going to write it up here, of 1,000 is 10. This is more than 10. Right? But it's less than 8,000, so it's going to be more than 10, less than 20. Is it going to be closer to the number 20 or closer to the number 10?
10.
10.
'Cause it's
10. So you could try 11, or I'm going to try 12, because I'm going to show you something. Because 2 times 2 times 2 is
6. No,
8,
8.
and it ends in an 8.
She taught us a magic trick.
15, cube root of 4,096. It's another one that you have to just try. It's not going to be there. The exact answer won't always be there. So it is 16. Number 16. The cube root of 4,913 is 17. Number 17. The cube root of 27 is not 9.
3.
It's 3 because 3 times 3 times 3.
Yeah.
Write that underneath of it. 3 times 3 is 9. 9 times 3 is 27. Cube root of 729 is 9 because 9 times 9. I want to see your work. 9 times 9 is 81. 81 times 9 is 729. Show that work. Now we can go ahead and put that off to the side. You don't put it in a folder, just put it off to the side. And be looking in your book page, Indiana 18.
Pencil or pen?
And now you're switching back to a pencil. Thank you. When I talk about vocabulary terms, it's this lesson that you really want to know your vocabulary terms because it makes it a lot easier. Some of this is stuff that you learned a long time ago for different numbers, but these two terms are fairly new for 7th grade. Rational. Before I read you the definition that they give you, I'm going to tell you the easy way of what a rational number is. A rational number can be a fraction. And fractions can be decimals, right? Because to change a fraction to a decimal, you just divide the fraction. So a rational number can be any number that but they call it a ratio. Well, isn't a ratio a fraction?
Yup.
And when I have a fraction, can I have the denominator be 0? No, never. Never. So, a negative number with a decimal can be rational. A decimal number that repeats, it can repeat the decimal. A mixed number, a fraction. Is it working? Anything can be a rational number. Irrational numbers are numbers that don't end. Okay? The decimal doesn't end. So like if I say the square root of 2. First of all, we're talking square roots and stuff. Does anybody know the square root of 2?
1.
I don't.
2.
1 times 1 is 1. 2 times 2 is 4.
Oh, no.
I'm not going to know
0.5.
what the square root of 2 is unless I use my calculator. There is no way for you to figure it out unless you use a calculator. So I'm going to show you how you're going to be using your calculator in this lesson to help you. Okay? Notice that this decimal doesn't repeat and it doesn't end. It keeps going dot, dot, dot. That means it's irrational. Okay? Irrational means it never ends.
Is pi irrational?
So pi is irrational because isn't pi 3.14 blah 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 blah.
6.
Okay?
3.14159.
But we usually end pi with 3.14. We usually end pi with 3.14, but it keeps going on and on and on and on, so it is irrational. Square roots of numbers we don't know the answer to are irrational. So numbers that are not rational are called irrational. The square root of any number that is not a perfect square number. I want you to underline that in your book. Not a perfect square number is irrational. The set of rational numbers and the set of irrational numbers together make up a set of real numbers. Study the Venn diagram below. Put a star here and a star here. You are going to need to know this chart. You're going to go back to this chart to find answers. Okay? It's going to become your friend. Now when I study this chart, this thing is called, we're going to start from the center and work our way out. Natural numbers, another word for that are counting numbers. Write that underneath your chart. You guys are used to saying counting numbers. So do counting numbers start at 0? Yes or no?
No.
No. If I say count to 10, do you say 0, 1, 2, 3, 4, 5?
No.
No. If I say count to 10, you say 1, 2, 3, 4, 5, 6, 7, 8, 9, 10.
1 Mississippi.
Those are counting numbers. After the counting numbers, so all counting numbers are whole numbers. The only difference with whole numbers than counting numbers is that you actually add the number 0. So whole numbers would be 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, don't keep going. Okay? So we've got the counting numbers. We've got they're all whole numbers. Now we have integers. What did I include in my blue here that I didn't have before? Negatives. So an integer is a negative whole number. Okay?
So like not negative.
Then with my rational numbers, I've now included decimals, negative fractions, and decimals that repeat. Over here with irrational numbers, it's just numbers like pi, and then this number here because it doesn't repeat, or the square root of 3. Do you know the square root of 3? I don't. I'd have to do it on my calculator. If I did it on my calculator, those numbers are going to repeat. So let's look, now remember, you're going to be using that chart. Name all the sets of numbers to which each real number belongs. So if I have the number 0.2525, what keeps happening?
2525.
25, 25, 25. Put a line above that 25.
25.
That means the 25 repeats. If it repeats, it's not irrational, but it's a decimal. So it fits in right in here, which are the rational number.
Oh.
And so I want you to underline that, rational number. Square root of 36. 6. We know the answer, exactly. It's 6, right? So a 6 would fit right in here, wouldn't it? 6 is a natural number, which is a counting number. It's a whole number. It's an integer. And so it's a rational number. You guys understand that. If it fits right in the center, it's going to be this, then the yellow, then the blue, and the white.
Yeah.
Because it goes all of them. The negative square root of 7. I don't know the square root of 7.
2.6.
So I'm going to use a calculator to find it, and they show it here. It's 2.645751311, and it's negative.
Numbers.
Does it repeat?
No.
No. The dot, dot, dot means it goes on forever and ever and ever, and we don't see anything repeating. So if it doesn't repeat, it's here in the irrational box. So the negative square root of 7 would be irrational. Let's do some problems together. Keeping in mind, we're going to keep coming back to this box. Do we know the square root of 10?
Yes.
What is it?
2 or 5.
If it's 2, that means 2 times 2. Well, that would be 4.
So then it has to be 5.
Well, 5
No.
times 5 equals 25.
Then
What times itself gives me 10?
1.
1 times 1 is only 1.
2 times 2 is 4. 3 times 3 is 9.
Okay, I like the way she's thinking. 1 times 1 is 1. 2 times 2 is 4. 3 times 3 is 9. 4 times 4 is
Nothing.
16.
That was-
Right? So there's no answer to that. But if I come here, and I hope you have your decimals calculator on your iPad, I'm going to pull it up. This is the wrong one though. You guys have to find the scientific one. You don't get to use this graphing part in 7th grade. But I still know down here is the square root sign, so I'm going to hit the square root. I'm going to put the number 10, and the square root of 10 is 3.1622. So we can't really say it's nothing, but we don't know the answer unless we use the calculator.
A number that I feel like
Does
writing.
this number repeat?
No.
No. So if I go back to my book, the square root of 10 is then considered irrational.
Irrational.
So under A, you need to write
You're right.
irrational. Negative 2 2/5. Can I make that an improper fraction?
Yes.
Yes.
So let's do it. 2
12.
times 5 is 10. 10 plus 2 makes 12. So I have
Negative
12 fifths,
2. Negative.
negative 12 fifths. If I have a negative 12 fifths, that is a ratio. So it's a negative number though, and it's not a whole number. So it's just out here. So it is a rational number. So under B, you're gonna write
Rational.
rational. I like how everybody's writing things down that I write on the board. C, square root of 10. You
100.
should know this.
10.
10.
You give us the answer.
Square root of 10 is 10. So I'm gonna put equals 10.
You need 100.
No. Oh, no. The square root of 100, maybe I just said that wrong. The square root of 100 is 10, thank you.
You're welcome.
So the square root of 100 is 10, so now I need to put 10 into a category. Well, what can I name it? 10 would be right in here, isn't it? So it's a natural number, because it's right there. It's also a whole number. It's also an integer.
It's also
And
counting.
it's also a rational. So you need to write all 4 down, starting from the smallest type thing to the biggest. So it's natural. We said natural and then went to whole numbers. And I'm going to use the number sign.
whole numbers.
Then it goes to integers. And then it goes to rational. Make sure you have all 4 of those written down. Look at the other next page. So now, not only do we have to know what rational and irrational are, now we actually have to compare the numbers. Whenever you compare anything, they have to be in the same form. Okay? Let's say I got 50% on a test, and Ethan said he got 2 out of 3 right. Can we compare those correctly yet?
No.
No, because if 50% and Ethan got 2 out of 3, I can't compare those unless I put them both in percents or both in decimals. What I want you to get used to is putting them in decimals. To put a percent into a decimal, it has 2 of these little thingies, I forget what they're called. You start at the right and you move left twice because it has 2 of those.
Polka dots?
So 0.5 is the decimal form of 50%. The decimal percent of 2/3, you take 2 divided by 3 to make it a decimal. So it's just numerator divided by denominator. 3 does not go into 2, so I add a decimal, bring it up, add a 0. 3 goes into 20.
8.
No, 6. 6 times 3 is 18. 2 left. Add a 0, bring a 0 down. 3 goes into 20. 6 times again. What's going to keep happening? It's going to be keep repeating. But I made them both decimals, so I have 5/10 compared to 66 hundredths, or which is repeating. So look at what you have in common. The tens place are different, right? So compare the 5 to the 6. 5 is less than the 6. So Ethan got a better score than I did on the test. So now that we've done an example over here to the side,
Good job, Ethan.
let's put it in now to where we compare them with the square root. Do you know the square root to 7?
Yeah, it's like
I don't,
2
because 2 squared is 4, 3 squared is 9. Well, we're asking the square root of 7. The square root of 7 is between the square root of 4 and the square root of 9. So it'd be between 2 and 3. But to get the answer, I'm going to go back to my calculator, and I'm going to just put the square root of 7. It gives me my answer. The square root of 7 is 2.6457. I'm going to stop there.
It gives it to us on the math book.
And it gives us in here in the math book, right? But I'm showing you how to get it on the calculator. Because did the math book show you how to get it?
No, ma'am.
No, and there's no way you can solve it without using a calculator. So we move that into decimals. Then I need to change 2 and 2/3 into decimals. They give me the answer, but how do I change that to a decimal? I need to show the work here. I need to make this a mixed number. So 2 times 3 is 6, 6 plus 2 is 8. So you're going to show me 8/3. Then you're going to show me 8 divided by 3. 3 goes in there twice. 2 left, add the decimal, bring it up. Bring down the 0. Goes in there 6 times. And what are we going to keep doing? Repeating. So now I can compare my 2 numbers. When I'm comparing my 2 numbers, the ones places are the same, the 10th places are the same, but the hundredths places are different. 4 is less than 6. So you have to do some work in order to compare. You can't just say, oh, it's less than, because I think it's less than. You have to make them both decimals. So if I go to number 6, or excuse me, number 5, changing 15.7% to a decimal. I want to see in your book that you do this. Move the decimal over 2 places. That's how you got that answer. How did I get the square root of 200? So underneath the bit, I'm going to write the word calculator. Because you used a calculator to get that answer. Then I can compare my 2 numbers. When I compare them, the tenths places are the same, so I can cross those off. The hundredths places are different, so I'm going to circle them. 4 is less than 5. And the 4 goes with this 2 hundredths. So 15.7% is greater than 2 hundredths. When you have to order a set, you do the same thing. Put them all in decimals. The square root of 30, I don't know it. So what did I use? Calculator. The 6 is just 6. 5 and 4/5. How do I get it to be 5.8? Over here. Show that you made it 29/5. And that's 29 divided by 5. And then that's how you find your answer. 5 and 36, which 6 is repeated, is about 5 and 37 hundredths. Then you can put them in order on the number line. You guys understand that? You're changing everything to a decimal, and I might be using a calculator. So if I come down here to my got it problems, the square root of 11. Do I know the square root of 11?
No.
No. So what am I going to use?
Calculator.
Calculator. And I'm just going to type in
11.
square root of 11, which is 3.316. Okay, I'm going to remember that. I'm going to come back to my book. This is where it's nice that you have your book on paper so you can copy it. So that is this answer right here. What should I do to 3 1/3?
Convert it.
Convert it. Make it a improper fraction first. 3 times 3 is 9 plus 1 makes 10/3. To change that to a decimal, it's like saying 10 divided by 3. 3 goes into 10 3 times. 1 left. Add a decimal. Bring it down. Oh, bring that decimal up. 3 goes into 10 3 times. What's going to keep happening?
Repetition.
I'm repeating. So if I repeat it, I'm going to just go one more time. So now I'm going to look. And I'm going to see that my ones places are the same. Tenths places are the same. But the hundredths places are different. And 1 is less than 3.
Good job.
Your homework. So hopefully taking all those notes, you'll be able to do it. You have 6 problems to do.
Ooh.
So you're going to look, oh, 6, really? You're going to look at the guided practice. You're going to do on Indiana page 20, 1 through 6. There has to be, for 1, 2, and 3, make sure you go back and use this chart. Some of them will have more than one name. Then if I go down to 4, 5, and 6, I have to show work. I don't know what the square root of 15 is though, so what am I going to use? A calculator and just put the answer there. Okay? Go ahead and pause it, Tanner.